right, let's go ahead and at least do some practice class code here. So first we need to create our header file, graph. We're going to call it Adjacency Matrix.hpp. If not, define. What?
I was wondering why you call it graph.
Graph AM?
Yeah, but now I realize you said adjacency.
Yeah, Adjacency Matrix. Do you want me to type it out? Graph Adjacency Matrix? Thank you. My fingers would
I don't
just.
want to do that either.
All right. So on our graph, is there anything we can template? Well, the nodes are integers.
Always.
Oh, so you don't have to like actually like.
Now you could template the nodes, but what about the weights of the edges? I mean, they could be integers, they could be doubles, they could be other values. So usually I'm going to template the weights. And instead of calling it class T, I'll call it class W for weight. Whoa, man, you got
Maybe
it.
we should do mass instead.
Mass.
Mass.
So class AM. No, forgot it does this sometimes. All right, we're going to have some private parts and some public as well. All right, Adjacency matrix. What's stored here?
Weights, nodes.
How's it stored? As a
Pointer? Kind of? As the word. Oh, as a
Matrix.
as a
2D array.
matrix,
2D vector.
a 2D vector. Okay, a 2D vector. How do we do that?
STD
Vector
I want to include that. Of vectors.
of.
Vectors.
Oh, we got a vector. A vector. Was it just vector? I already forgot.
I think it's yeah.
Sure. And what are we storing inside of it?
Weights.
Weights. And don't forget the space here, or sideness will occur. I'll call it the M graph. All right. Wow, that's good. Good job. Well, we need a constructor. And let's see. We should also have another constructor. Reverse these probably be a good one as well. What are the functions we wanted? Clear. Oh, we'll skip that for now. Determine whether the graph is empty. Oh, that's not. Create the graph. Well, it doesn't. Okay. Wow. Add vertex. And then void delete vertex. So you're not going to like that one. Void add edge. And start constant int end. That one's going to be easy. And then W.
What is the data type of an edge?
That's our weight. The weight. Because we're storing it as a matrix, so the only data types we're storing is whatever our weights are, which in this case are integers.
So
But it may need to be a complex class if you're trying to do really complicated things. Yes?
So there's technically, like, there is an edge between everything, but we
No.
only give weights to.
No. There is no edge from 2 to 4.
Well,
That-
in the matrices.
Oh, in the matrix, we are storing what the weight is between the edge to 2 to 4 in there. But is there an edge? No, so we're signifying it doesn't exist by putting an infinity sign over here. In the code, we're going to have to do something else. But
Like an X.
like an X,
Or -1.
-1. Okay. Yeah, we're gonna do it with -1s.
Okay, what about 10,000?
We're gonna do -1s.
10,000.
Yeah, that's awesome.
All right, adjacent, and we'll do constant int. And all right, and then what do we need to do? We need to be able to traverse the graph. Ooh, we'll get to that in a moment. Let's get this code working first, and then we'll talk about traversal.
Traverse. Question mark? What is traverse?
What is traversal? No. All right. Got a new one. Let's see. Can we make it? Oh, good. We can. So it compiled. Ship it? No, I'm kidding. All right. Y 5 down, tab new, source, graph. We'll make the CPP file now. These are all the things your professor does for you.
Yes, we appreciate it.
Thank you for finally mentioning that.
Hey,
You're the best professor.
Do that there. Now we got to do graph am of weight here. Oh boy, this is gonna be a while. Not too while. All right, we got that. Let's go and make them curly brackets. Good. Boom, 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 boom. And now we need to add the whole template thing. Template class W, YY, paste, 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 paste. Let's go and space that out. All right. Does that look fine so far? What's this?
we were joking about how like fast you move it and how we wish we could move it that fast.
Oh, just learn VI.
Huh?
Just learn VI.
Yeah, I know. But like I use the
Make good. We did it right. Well, that's VI.
these other stuff.
All right. If it's empty, now let's not do this one first. If we have a certain number of vertices, what do we need to do? Well, what's our only data structure is this guy over here. So let's copy him over here so we have a note of what's going on. So what do we need to do here?
Populate the graph.
We need to populate the graph. So,
Number of vertices.
all right, so we got number of vertices. So what do we do? mgraph dot, what do we need to do to this graph? Bet you all wish you had that little drop down thing right
Don't we need to
now.
like reserve the spots?
Yeah, so resize. How many?
Number of
The number of vertices. Perfect. All right, are we done?
Yes. We need to do it for the inner.
Yeah, for the inner ones as well. So we need to do a for int I equals 0, I is less than number of vertices, I plus plus, and then for each section, dot resize, how many?
Number of vertices.
Number of vertices. All right. Let's see if that compiles. It did. Man, we're doing great. All this stuff is compiling. All right, so tests. All right, let's create a simple test. We'll do creation test. Tests, creation test. All right, so let's go ahead and include the graph am. Or I'm sorry, it's all lowercase, isn't it? Graph am.hpp. We'll do graph am of integers just to make life easy. We'll call it graph. We'll give it 100 vertices. All right, we're just going to do that. Make creation test. Ooh. Undefined reference to passing in an integer. Did we not write that in? Passing in an integer? Passing in an integer. Ooh. Hmm? Undefined reference. Ooh, does anyone see it?
Just the compiler being wrong.
Being ornery?
No, the compiler's being wrong.
The
Yeah.
It's the only
Yeah.
possible
Yeah.
explanation.
Happens.
I actually don't see it right now. What are we doing wrong?
Spelled it wrong.
Spelled it wrong?
Spelled it wrong.
Spelled it wrong? Did we spell it wrong? Graph am, graph of
I
100.
don't know. I was just.
Well, what happens if we don't put anything in here? Is it going to take that? I didn't think so. So it's not adding something correctly. Filter, source, test. Nope, that's all in there. We're good there. Let's see if the main file has the same issue. Alright, it doesn't have that issue. Alright, let's try and create it. Nope, it does not like it. It is including the CPP. And here is the CPP. You include it. And oh, classic. Guess what we didn't do? Because it's templated.
Yeah, I figured that was the issue. But
You wanted to watch me sweat for a little while just because? Yeah, I see how it is. You must include the CPP when using templates.
That's actually gotten me before.
Yeah. Yeah, I wish they would fix that. And now we can make it. Oh good, now we just have errors.
You just made it worse.
Previously declared here.
Oh, it's got a problem with the graph.
Yeah, the other issue is now, hold on. If not defined, define it, include everything, then include the CPP, which tries to include it but can't do it again because it's already done. And then, what's your problem?
I thought at the beginning of the CPP we did like include graph am.h.
Right, so if not defined, I think you have to do this again. Graph underscore h. I really wish C++ would fix this, because it's really frustrating. There we go. Warning, extra tokens at... There's extra tokens.
you said mdiv graph page. It's just mdiv. Am I wrong?
Oh, thank you. There we go. Now you just have undefined row. Okay. Alright. 1 second while I look up what I'm supposed to be doing, because apparently I cannot remember anymore. Oh, I didn't even give you the source code. Oh, that's cute. So, priority queue.cpp, if defined and right. Isn't that what I'm doing? If, oh, classic. There we go. I accidentally put if not defined. Silly me. Alright, now that's been fixed. Make creation test. Alright, one day C++ will solve that problem and I will be happy. Can we make it with 100 elements?
No, it's not gonna solve that problem. This is gonna be dumb forever.
It is going to be dumb forever. Alright, didn't give me a seg fault. That's great. Okay. So, delete a vertex, add a vertex. Let's not do that yet. Add an edge. Oh, hold on a second. I lied. Are we done?
So we made the matrix.
We made a matrix.
Okay. Matrix
What?
doesn't have any values yet.
What are the values?
They're
Undefined.
They're undefined. What should we do about that?
Put them all at 0.
I was hoping you'd say define them.
What should we set them as?
Yeah, what should we set them at? We just created a graph with a bunch of nodes. So which values can we have? -1 for everywhere except?
The ones where it's the same number.
Right, the ones are the same number. All right.
Ones where I equals j.
All right, so we're...
We can just change it, and if they can't go there, we can...
So I'm going to skip a bit and go void clear. I clear edges. There we go. Graph AM of W. Go template class W, and then we'll just create. All right. So we want to clear the edges. How do we do that? We go for int I equals 0, I is less than m graph dot size I plus plus for int j equals 0, j is less than m graph sub I dot size j plus plus. Wow, there's a lot of typing. So normally we'd have m graph sub I sub j equals to, yeah, we'll just say -1 for the sake of argument. Except for If what?
I equals j.
If I equals j. I'm lazy right now. And then we'll just call clear edges. Isn't that great?
Yes.
Oh, yes.
It's
All right. Do y'all need me to comment this?
no.
I just realized I have not been commenting.
That's fine.
Good.
I don't comment either, so.
If it was hard to write, it should be hard to read.
Yes.
I comment if like what I'm doing is not working, and I'm just like, well, here,
I
let me
usually just
say what I wanted to do.
comment on the code that doesn't work. Like, all right.
All right. Didn't cause a seg fault, so hopefully that's okay.
So we do our constructor now?
Yeah,
We-
can we print it?
Yeah, let's do print. That's a great idea.
That would help. That's like one of the first functions I made.
It's one of the best functions always to make.
Picture it in.
No, because what I'm picturing in my head is probably not what's happening.
All right, we'll set up these wonderful for loops again. std c out, do m graph sub I sub j, and then we'll give it a space, and we'll give it a space. Good. And actually after each of these we'll do, we'll keep wanting to do printf. And let's go ahead and include IO stream. Perfect. All right, so does that compile? Great. Maybe we should make that part of our test.
Wow.
That's good. Actually good. How about we trim this down to 10?
Yeah, that would be nice.
Hey!
Why is it, wait, what's your, yeah. Oh, it's because it's on mine up there.
Oh yeah. Okay. So let's go ahead and do another new line so it's easy to see.
What?
Nice semicolon.
Yep.
What? Hey, he caught it.
Caught it.
Nice, nice.
David caught it, guys.
David caught it. Thank you, David, very much. Your new name, David?
Might be no good at code, but David.
That David guy.
That David guy. All right. How about that?
Looks good. Looks good.
Sure. It's not quite lining up, but that's okay. We don't care right now. Okay. So, we have some confidence we're doing something good. We'll forget adding and deleting a vertex for now. How about adding an edge?
Change the.
You know what we didn't add to? We didn't. I'm sorry. This is completely wrong. Y'all should have told me.
Oh yeah, you had to have a wait.
Yeah, you gotta have a wait.
Want that wait.
I said something earlier.
Yeah.
All right, now that we have a wait.
You set the vertex of start end to be equal to, I mean, what's the name of the M graph?
So
Start and
m graph of
Start it.
start and end.
equals.
Wait. All right.
That's all we need.
So
As long as it's not, you can't override the zeros yet. I might want that.
see, someone's starting to think like Dr. West. That's good. All right.
Could you travel to yourself then?
Huh?
Could going to yourself have a wait?
That's a good question. Do we want
Could you get on
that?
a plane and do a big loop and come back and that costs 20 bucks?
We could do that. We'll go ahead and we're going to allow that. But that you're thinking along the right lines. What else could go wrong here?
It could be out of bounds.
Out of bounds. I'm going to let y'all fix that. Oh! All right. What do we have over here? We have 0, 3 is 17. We have 0, 4 is 11. Let's go ahead and dump this down to 5, make it even easier. I like where this is going. Let's add an edge. What do we have? 1 to 0 is 14. I'm just, people at home, I'm reading off the board, which is this thing over here. So we had 1 to 0, what's the next one? 1 to 3. And that value is,
So,
I'm looking right over here, guys.
oh, yeah, same. I'm looking over there too. I was.
Yeah. I'm looking over at this thing because that's what we're creating.
Yes.
The next edge we have is from 2 to 1. And what's the value?
50.
All right. Someone besides the new David? We have a... Nice, thank you.
You missed the one before.
I did? Oh, I totally did. All right. What else do we need? 4 to 3. And that weight is... All right, let's go ahead and see what that does. Okay. Some spacing issues, but that's okay. Actually, we could fix that spacing issues. And this will only work for very small graphs, otherwise it's going to look terrible. There we go. You don't like it?
No, it's fine.
It's fine.
You prefer the old version, Matt? I mean, David?
It's fine.
Do you want me to turn it back?
Oh, it's fine. Bless you.
Okay, fine. All right.
Use 10,000 to win that.
So how do we find out if something's adjacent?
We look at in graph start in and see if there's something other than -1.
All right, so return m graph sub start sub in does
I
not.
think that recursion, you
No,
know.
we're not doing that. We're doing adjacent, not is connected.
Yeah.
Is connected is different. This is just adjacent.
Oh.
Hold on, man. Let's not get too ahead of ourselves. Yes.
Would that return a Boolean value?
Yes, it would. How about we do that? Then that returns the weight.
You want the weight?
Yeah, don't we want the weight? Probably should call it adjacent weight. That'd make more sense, wouldn't it? Yeah. Let me spell it correctly as well. Yeah, what was I thinking there? All right, see if that compiles. Great. Let's see if we can do some testing here. So 7 should be the graph.adjacent weight from 1 to 3, right?
Yes.
Okay.
All right, we're passing our first test case. And then, how about 11, 0, and 4?
Yeah.
And say 11 from 0 to
0 to 3, okay.
Do a wrong
3.
one.
Yeah, do it wrong.
Do a wrong one, just make sure our test cases are working.
Yeah. There you go.
Failed, yeah, so our test cases are working. So change it back. Oop, we're still failing.
Yeah, that was you.
Put in 17.
Yeah, you had 17.
From 0 to,
7.
oh,
That's out of bounds.
That's
Yeah.
We can't do that one.
all right, what's another one? 4,3, here we go. Yeah, we're doing great. All right, now, let's start to get a little tricky. Should that be correct?
Yes.
All right. Okay. What would be a -1, 1?
2 and 3.
Okay. Let's leave that test case as it is. That's a good test case for creating a basic graph, printing it, and then just making sure our adjacencies are correct. Right? We're good. We're gonna leave that test alone. All right. I think we now have a good idea of how to build a basic basic graph using the adjacency matrix. So I'm going to pause here on the video, and then we're going to go into the next subject, which is probably traversal.